class we have done the relativistic part of Dirac Hamiltonian, and we have seen that even Dirac free particle is self-accelerating, isn't it? You can say this is self-accelerating. अपने आप उसके internal behavior के कारण उसमें acceleration आ रहा है. Either it may be the case of relativistic or the case of spinning or internal rotation. उसके कारण आपका acceleration हम देख रहे थे. So now let's try to go for application of all this Dirac Hamiltonian on the charged particle in a electromagnetic wave or in an electromagnetic field. So what is classical Hamiltonian? So classical Hamiltonian in an electromagnetic field is given by, and that value is P minus QA upon C, where A is some vector potential. Okay. So I think you have already done this thing, the concept of vector potential and all this thing, है ना?
Yes, sir.
So we will just try to apply all this thing here. Okay. So just a minute. Okay. So here is charged particle, and this charged particle is Q, and A is your vector potential, and this is square C square plus M square C4, and this is root under, and you can just say Q phi. So this is your Hamiltonian for this is your classical Hamiltonian. Okay. So you can use this thing as a classical Hamiltonian. So what will be your Dirac Hamiltonian? एक बार तो यही क्वेश्चन पूछ दिया था. What will be your Dirac Hamiltonian? The Dirac Hamiltonian. Now this thing can be replaced by pi. So you can write this whole thing is H is equal to pi square C square, and you can take pi vector plus M square C4 to the power 1 by 2 plus Q phi. So what will be your Dirac Hamiltonian? Your Dirac Hamiltonian is C alpha dot pi plus beta MC square. So this is due to this fact, and here you have Q phi. And again, you can put the value of pi. What is value of pi here? The value of pi is C alpha dot P minus QA by C whole square plus beta MC square plus Q phi. So this is your Dirac Hamiltonian, isn't it?
Yes, sir.
Clear है ना?
सर
Yes.
सर इसमें वो जो क्लासिकल हैमिल्टोनियन है
हाँ.
तो सर कैसे आता है सर माइनस क्यू बाई सी कैसे
कैसे आता है ये? This will be part of electromagnetic theory. Okay. आप वहां पर एक बार इलेक्ट्रोमैग्नेटिक थ्योरी में देखते हो, अदरवाइज आई विल डिस्कस इट लेटर. सो P माइनस क्यू ए बाई सी क्यों आएगा, कैसे आएगा? आप यू कैन राइट द लैग्रेंजियन इन अ इलेक्ट्रोमैग्नेटिक फील्ड. ए और V है तो वहां से लिखोगे, फिर वहां से आप इसको इजिली कर सकते हो. ठीक है. आई विल जस्ट गिव यू सॉल्यूशन, डोंट वरी. ओके.
ओके
So suppose, and the question in the quantum mechanics was, suppose this is your classical Hamiltonian, what will be the corresponding Dirac Hamiltonian? So this is given to in your exam, okay? And we can also prove it, how it will come. That is different issue. But I am just trying to, sorry, this is not square, na? This is P minus QA, not square. This is P minus QA by C plus beta MC square. Now let's try to solve this particular Hamiltonian by putting, some लोग free particle के लिए कर रहे हैं, something like, so this will be phi is equal to 0. So there is not any scalar potential. We are just trying to solve it for this particular Hamiltonian. इस particular Hamiltonian को solve करने की कोशिश करते हैं. Okay? So let's try to go for this. And we will see how the spin part and Lande factor will come into picture. वो किस तरह से पिक्चर में आता है वो हम जरा देखने की कोशिश करते हैं. What we have H is equal to alpha dot pi c plus beta mc square. And what I have the psi for a free particle. This is just like as a free particle, isn't it? This is something like free particle. So this can be written as something, let's say chi and phi. This will be its the magnitude part, or this can be said as what? A spinor of a this 2 cross 2 matrix, because this will be just, you can write it in 2 cross 2 form. So this is your kit part, which will be just going to satisfy this equation. So what is going to happen, and you can just put this e to the power I k dot r minus omega t, okay? And this is your complete solution. So this is your complete solution. So you will surprise that quantum mechanics give you the opportunity to write matrix and function together. Quantum mechanics में यहाँ पर ये आपको opportunity मिल सकता है. Anyway, so what we are going to do, and this omega can be written in form of energy. So this k can be written in form of momentum if you are going to multiply with h cut, isn't it? अगर मैं इसे h cut से multiply कर दूं और divide कर दूं, multiply कर दूं, divide कर दूं, then we can write it in form of momentum and energy. And this is the basically spinor part of this particular wave function. So what will happen? So this will be, this is your basically I h cut d upon dt psi, and this value is psi alpha dot pi plus beta mc square. And what will be this value? This value have some energy, because if I am going to divide by h cut here, then this will be time part will be associated with the energy. So this value is equal to, I can write this E, and if I am writing E in the matrix form, I can write this thing as something like this, isn't it?
Yes, sir.
Because this is the eigenvalue of this particular Hamiltonian. And here we can write chi and phi must be equal to, this particular value is, what is this particular alpha? Alpha is equal to 0 sigma 0. Last class में किया था ना?
Yes,
Dot pi. And what will be your beta? Beta is nothing, 1 0 0, and this is identity matrix actually, and that
Minus
value is
yes.
mc square.
Yes, sir.
Isn't it? है ना? And now
Yes,
we
sir.
can write it, and obviously we have to apply this vector also here. We can apply this particular vector. So what will happen? So we can write E minus mc square, and this thing will come into this direction. This thing will come here. So what will happen? This value is what? Minus sigma dot pi into c. होगा ना? And
Yes,
this
sir.
value is minus c sigma dot pi, and this value is E plus mc square, and we have chi and phi that must be equal to what? 0. Clear है ये?
Yes,
Now we just want to solve these two equations simultaneously. So अगर आप इसे solve करोगे, then what is your first equation? E minus mc square chi minus c sigma dot pi must be equal to what? 0. The second equation is minus C sigma dot pi plus E plus MC square. Sorry, here is chi and here is phi. Must be equal to 0. So we have to try to solve these two equations, and let's try to see how we are going to solve it. So let's try to go for this one. यहाँ तक clear है ना?
Yes, sir. Yes, sir.
Okay. Now let's try to go for this one. इसको अगर आप लिखते हो, then how you will write this particular thing? We can write pi is equal to C sigma dot pi upon E plus MC square chi. लिख सकते हैं ना?
Yes, sir.
Yes, we can
Okay.
write this particular thing. Now, E plus MC square is nothing but total energy of a system, and which will be, sorry, E is what? Total energy of a system, and E can be written the kinetic energy plus MC square. E can be written kinetic energy plus MC square plus 2 plus MC square. लिख सकते हैं ना इसे? इस पूरे टर्म को? ES is nothing but what? Kinetic energy. ES को क्या ले रहे हैं हम? Kinetic energy के टर्म में को ले रहा है. लिख सकते हैं इसे?
Yes, sir. Yes, sir.
Huh? Yes. And what we want here, we want that this kinetic energy is very, very less with respect to this MC square, such that we can approach it in a classical region. ऐसा कर सकते हैं क्या?
Yes,
अगर
sir.
classical region के लिए हम जाना चाह रहे हैं, then what we are saying? We are saying ES is very, very less than MC square. So I can write E plus MC square is nothing but equivalent to 2 MC square. We just want to go into region where we can write my kinetic energy as P square by 2m. Are you getting my point?
Yes, sir.
अगर मैं वैसा लिखूं तो हम इस पूरे चीज को इस तरह लिख सकते हैं. Now look at here. What is going to happen? So this phi is equal to C sigma dot pi, and this term can be written as 2 MC square, isn't it? Into chi. And now look at the first term. First term is very interesting. What is your first term? The first term is E minus MC square is into chi is equal to C sigma dot pi pi. लिख सकते हैं ना इसे? This is your first term. Are you getting my point?
Yes, sir.
And now what is E minus MC square?
Kinetic.
That is kinetic energy.
0, sir.
So this will be nothing but
Okay.
what? Kinetic energy chi is equal to C sigma dot pi, and I can write phi from here. So that value is equal to C sigma dot pi upon 2m C square chi. Are you getting my point? So what will happen?
Yes, sir.
This C square will cancel out, and you have this kinetic energy as a form of sigma dot pi sigma dot pi by 2m chi. Yes? And look at this, is something like P square by 2m. Are you getting my point? The symmetry is exactly same, isn't it?
Yes, sir.
Now look at So whole challenge is that what will be value of sigma dot pi into sigma dot pi? Let's try to calculate this thing. If we are able to calculate this particular thing, we can easily calculate what will be my kinetic energy of a charged particle in a vector potential A. So let's try to go for this. And here we have the basic property of Pauli spin matrices. What is the property of Pauli spin matrices? That you have if sigma dot A into sigma dot B, then you have A dot B plus I sigma A cross B. Sigma dot A cross B. I think I am correct here. सही है ना ये? Yes, this is your correct expression. Now, what we want, we have to calculate this particular thing. ये एग्जाम में आ चुका है, तो आप प्लीज ध्यान में रखना. इसके हर एक डेरिवेशन का कोई भी पार्ट आपके एग्जाम में पूछ सकता है. ओके, सो दिस वैल्यू इज इक्वल टू सिग्मा डॉट पाई into sigma dot pi, and that value is equal to what? Pi dot pi plus I sigma dot pi cross pi. Yes, pi dot pi is pi square. Now we have to calculate what is pi cross pi. If we are able to calculate pi cross pi, then obviously we can calculate each and everything in a very nice way. So just give me next 5 minutes. We are able to calculate all this thing. So what is pi cross pi? We have to calculate pi cross pi. So don't worry, this is not zero. एक बार एग्जाम में यही आया था. And what is pi? Pi is nothing. P minus QA by C cross P minus QA by C. होगा ना? And what we are going to do, we will just open it. So what will happen? P cross P plus Q square C square A cross A. Yes. And what will happen? Minus Q upon C P cross A minus Q upon C A cross P. Are you people comfortable?
Yes, sir.
ठीक है. And now what we are just trying to calculate, we are just going to apply some vector on both sides. तभी तो equivalent निकाल सकते हैं ना. Let's say some vector, get psi vector is on both sides. Anyway, P cross P is what? 0. This is simple momentum. P cross P is momentum. A cross A is what? That is 0. Now, what will be P cross A? So P you can write. Now I am just going to calculate minus Q by C. You can write P is minus IH cut del cross A. Isn't it? And what will be del cross A?
B.
B, magnetic field.
Magnetic field.
And here you have Q by C, A cross minus IH cut del. And if you have A cross del, and del will operate on some psi, del will operate on some vector, what will be that value? That value is always 0, isn't it?
Yes, sir.
Del किसी भी, del is vector. This is vector quantity. It will operate on any field. That value is what? 0. वो हमेशा किस पर operate करेगा? किसी न किसी scalar function पे operate करेगा. Isn't it?
Yes.
Okay. So this value is 0. Only one term is going to survive, minus minus plus, and that value is equal to I upon H by C. And here you have B. Del cross A is what? B. So you can put I upon H, and Q is also there. I H Q B upon C. Now let's try to go for द फाइनल वर्जन। फाइनली हम इसे देखने की कोशिश करते हैं क्या मिल रहा है हमें। सो ऑब्वियसली वी हैव टू फाइंड दिस पर्टिकुलर वैल्यू। ओके, सो लेट्स ट्राई टू गो फॉर दिस वन। सो दिस क्या हुआ?
ग्राफ जब
बताओ।
डेल कोई वेक्टर को करेगा तो सर डाइवर्जेंस
क्या बोल रहे हो?
सर जब कोई डेल सर वेक्टर के ऊपर ऑपरेट करेगा
दैट विल बी जीरो।
सर वो तो डाइवर्जेंस होगा।
डाइवर्जेंट कैसे हो गया? अगर किसी फील्ड के ऊपर ऑपरेट, डेल किसके ऊपर ऑपरेट कर रहा है? दैट विल ऑलवेज ऑपरेट ऑन सम स्केलर फंक्शन।
यस सर।
कहां देखा है तुमने उसको किसी फील्ड के ऊपर ऑपरेट करते हुए? देखा है क्या? हाँ,
नहीं नहीं नहीं, ऑलवेज स्केलर के ऊपर ऑपरेट।
दैट विल बी ऑलवेज ऑपरेट ऑन सम स्केलर फंक्शन। ओके, एंड साई जिसे आप साई किट करो, दैट दे आर जस्ट लाइक अ फील्ड, इजंट इट? Okay, so what we have this particular thing as, so this es into chi is equal to what we have? Pi dot pi plus I sigma pi cross pi by 2m. यही है ना? And here is your chi. And what is this value? This value is P minus QA by C whole square upon 2m. And look at this value. This value is equal to I, and sigma is there, dot, what is pi cross pi? Pi cross pi is I Q H cut B upon 2mc. सही है ना? And what is I dot I? Is I into I is -1, and chi is also there. So this is your chi. Now look at what you will get here. So here we have P minus QA upon C whole square by 2m plus, or that thing is actually minus, and you have Q upon 2mc h cut sigma dot b. Yes? लिख सकते हैं इसे?
Yes, sir.
And for the spin half particle, if I just want to write this thing, if I am just going to change it with the charge of electron, I just want to change it with the charge of electron, and I just want to introduce S here, then what will happen? H cut by 2 is there, isn't it?
Yes, sir.
So what will happen? So this can be written as 2 times E upon MC H cut by 2, or you can just go for S dot B. ऐसा लिख सकते हैं ना? लिख सकते हैं इसे?
सर इलेक्ट्रॉन के लिए क्या सर?
क्या?
सर इलेक्ट्रॉन के लिए क्या सर? तो सर वो तो h कट बाय 2 होगा ना सर?
तो वही तो बोल रहा हूँ, ये दिस इज, आप इसको इस तरह से देख सकते हो ना, मैं स्पिन के टर्म में लिख रहा हूं, आप इसको ऐसे देख सकते हो, Q बाई MC H कट बाई 2, isn't it? ऐसे लिख सकते हैं इसे?
यस सर.
Yes या no? And
sir.
this value is equal to Q by 2, and that value is equal to sigma dot B. ऐसे लिख सकते हैं या नहीं? एंड
हाँ
व्हाट इज
सर,
दिस पर्टिकुलर वैल्यू? एच कट बाई टू सिग्मा से मल्टीप्लाई कर तो
सर
एस
स्पिन।
मिल जाएगा ये।
यस सर। हाँ सर, वो कल वो समझ नहीं आया था, मल्टीप्लिसिटी समझ नहीं आई थी सर। ठीक है
Are you
सर।
getting my point? So this will be some
हाँ सर।
s, and now what you will
सर,
get? You will multiply it with by 2 and multiply with by 2, and now you can have this particular thing. E को आप इसको यहां पर E से replace कर दो, and if you are just going for H cut here, then this will be what? Bohr magneton, and here you will got the value G. That G value is equal to what? 2. मिलेगा ये?
यस सर।
आप इसको
Yes,
बोर
sir.
मैग्नेटॉन के टर्म में लिख लो, डोंट वरी। व्हाट इज दिस वैल्यू? दिस वैल्यू अगर ई से मैं मल्टीप्लाई कर दूं तो ये वैल्यू क्या हो जाएगा? ई एच कट अपॉन 2mc, एंड दिस इज व्हाट? बोर मैग्नेटॉन। हाँ या ना?
Yes, sir.
यस सर, यस सर, यस सर।
That is for the Bohr magneton. This will be your mu b. Yes, in the Gaussian unit. So this will be your Bohr magneton in a Gaussian unit. So अब अगर आप यहां पर 2 से मल्टीप्लाई कर दो और यहां पर 2 से डिवाइड कर दो, then we will get the this g vector.
Yes, sir.
यस सर।
आप मिलेगा कि नहीं आपको g फैक्टर यहां पर? And
Yes,
that
sir.
g
Yes,
and
sir.
that
Sir.
g factor is what? Lande g factor of for the basic
electron.
electron. So from
Yes,
here
sir.
we can derive the value of g, and this g is equal to what? 2. है ना? यहां से हम derive कर पा रहे हैं g is equal to 2. And now look at here. The most important thing is that this is your kinetic energy of a particle in a vector potential A, and this is something called translation kinetic energy, because p
Yes, sir.
square by 2m type से है चीजें. Yes.
Yes, sir.
So this is your translation kinetic energy, and this is kinetic energy that your spin half particle is going to couple with magnetic field, who will generated by the A potential, isn't it? क्योंकि ये magnetic field
Yes,
कैसे
sir.
कहां से generate कर रहा है? That is generated by del cross A is equal to what? B. So this is generated by this A itself. अब B को लिख सकते हो del cross A, है ना? So now you can see that kinetic energy have a internal structure, जो आपका स्पिन का internal structure है चार्ज पार्टिकल के लिए, उसको आप इजिली यहां पर इनकॉर्पोरेट कर पा रहे थे, जिससे कि और कोई भी किसी भी मेथड से हम इनकॉर्पोरेट नहीं कर पा रहे थे अपनी कैलकुलेशन में. आर गेटिंग माय पॉइंट?
Yes, sir.
Yes, sir.
And this is all about your theory behind the charged particle in a electromagnetic field, जिसका वेक्टर पोटेंशियल A दिया हुआ. Obviously, if there is some vector potential, you can easily calculate what will be your magnetic field. Clear है ये?
Yes, sir.
Yes, sir.
Okay. कुछ पूछना है यहाँ पर?
No, sir, अभी तो नहीं है।
Okay. So this is I think this is more than enough for your relativistic quantum mechanics. क्योंकि आपके एग्जाम में जो भी आएंगे वो बेसिक क्वेश्चंस आएंगे. Obviously, this is the first chapter of relativistic quantum mechanics. जिस तरह से हमने quantum mechanics पढ़ा है, उतना ही फिर आगे आपको relativistic quantum mechanics में पढ़ना होगा अगर आप इस पर कमांड करना चाहते हैं. So, but this is not in our course. We have to just give the introduction of Dirac Hamiltonian, and we have just done one problem, and this is the one of the simplest problem, isn't it? अब इससे भी अब हाइड्रोजन एटम की कैलकुलेशन और बाकी सारे कैलकुलेशन हम डिराक इक्वेशन के थ्रू कर सकते हैं, डिराक हैमिल्टोनियन के थ्रू, बट दैट इज आई डोंट थिंक दे आर इन योर कोर्स. ओके, सो आई थिंक वी मस्ट स्टॉप
Yes, sir.
हियर. सो दिस इज योर पार्ट. प्लीज इसके डेरिवेशन सारे जरूर कीजिए, बिकॉज the question will ask from the derivation part. Okay, ठीक
Yes,
है.
sir.
So और आपके बुकलेट में भी मैंने सारे क्वेश्चंस को, सारे डेरिवेशन को क्वेश्चन के फॉर्म में दे रखा है. सो आप फटाफट करोगे तो आपको बहुत ही आसानी होगी. ओके.
Yes, sir.
Yes, sir.
ओके, सो दिस इज ऑल अबाउट योर रिलेटिविस्टिक क्वांटम मैकेनिक्स. नेक्स्ट क्लास में हम लोग बात करेंगे स्कैटरिंग के बारे में, ठीक है।
थैंक यू
Yes.
सर।
थैंक यू।
Thank you, sir.
थैंक यू सर।